Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the introduction of RNA splicing mechanism or the RNA splicing machinery. Is it clear? So what exactly happens during the splicing mechanism or during the splicing process? So if we consider one particular double-stranded DNA, so when the double-stranded DNA, when it participates in the transcription mechanism or in the transcription process, it synthesizes in single-stranded mRNA. Is it clear? So here the specific single-stranded mRNA which has synthesized during the transcription mechanism or the transcription process, it possesses or it consists of both the coding sequences and as well as the non-coding sequences. Is it clear? So for your better understanding, let me print it on the board. So here let us assume it as the double-stranded DNA. Double-stranded DNA, right? So when the double-stranded DNA, when it participates in the transcription mechanism, is it clear? So when the double-stranded DNA, when it participates in the transcription mechanism or in the transcription process, it synthesizes in single-stranded mRNA. So here it is nothing but the single-stranded mRNA, right? So here the single-stranded mRNA, it possesses or it consists of both the coding sequences and as well as the non-coding sequences. So here it is nothing but the non-coding sequence. So here it is simply termed as intron. And again it is nothing but the non-coding sequence or the intron. Is it okay? And again here it is nothing but the non-coding sequence or the intron again. Intron. And again here there is an availability of one more other non-coding sequence or the intron. So here it is nothing but the primary transcript which has synthesized during the transcription mechanism. So here the specific primary transcript which has synthesized during the transcription mechanism or the transcription process, it possesses both the coding sequences and as well as the non-coding sequences. So here the non-coding sequences, which are nothing but the introns, they do not have any prominent role or they do not have any biological activity. Is it clear? The specific non-coding sequences are the introns, they do not have any biological activity. So the reason why before the exporting of the specific eukaryotic mRNA from the nucleus to the cytoplasm, the specific non-coding sequences are the introns, they has to undergo the splicing mechanism. So when the specific eukaryotic mRNA, when it participates in the splicing mechanism or in the splicing process, the non-coding sequences are the introns, they undergo successful splicing. So when the non-coding sequences are the introns, when they get successful spliced out, under such condition, it leads to the formation of a mature mRNA or intron-free mRNA. Is it clear? If we consider one particular eukaryotic mRNA, out of the 100% of the eukaryotic mRNA, around 80 to 90% of the eukaryotic mRNA, it is composed of non-coding sequences or the introns. And these non-coding sequences are the introns, they do not have any biological activity. So the reason why the non-coding sequences are the introns, they undergo successful splicing. Is it clear? So when the specific eukaryotic mRNA, when it undergoes successful splicing, under such condition, it leads to the formation of an mature mRNA or intron-free mRNA. Is it clear? So let me print it here. Splicing. So here there is an availability of only the coding sequences or the exons. mature mRNA. mature mRNA or intron-free mRNA. Is it clear? So here the number of non-coding sequences or the introns, it remains vary from one particular living organism to the another living organism. In all the living organisms, the number of non-coding sequences or the introns, they won't remain similar. It remains vary from one particular organism to the another organism. So if we consider in case of yeast, there is an availability of only one particular non-coding sequence or the intron. And if we consider the titin gene of the humans, in case of the titin gene of humans, there is an availability of around 363 non-coding sequences or the introns. Is it clear? So let me write it here. In case of yeast, there is an availability of only one particular non-coding sequence or the intron. And if we consider the titin gene of humans, there is an availability of around 363 non-coding sequences. And even the size of the non-coding sequence or the intron, it remains vary from one particular organism to the another organism. So as the genome complexity increases under such condition, the size of the non-coding sequence or the introns, it also increases. Is it clear? So now here my question is, what exactly happens to the specific eukaryotic mRNA if it won't participate in the splicing mechanism or in the splicing process? If the specific eukaryotic mRNA, if it won't participate in the splicing mechanism or in the splicing process, under such condition, the non-coding sequence or the intron, it remain in association with this particular eukaryotic mRNA. So once when the non-coding sequence or the intron, when it remain in association with the particular eukaryotic mRNA, under such condition, once when the specific eukaryotic mRNA, when it exports from the nucleus to the cytoplasm, under such condition, the specific ribosomal subunit, instead of encoding the coding sequence or the exon, the specific ribosomal subunit, it encodes the non-coding sequence or the intron. Is it clear? So once when the ribosomal subunit, when it encodes the non-coding sequence or the intron, under such condition, specific ribosomal subunit, instead of encoding the coding sequence or the exon, the specific ribosomal subunit, it encodes the non-coding sequence or the intron. So once when the specific ribosomal subunit, when it encodes the non-coding sequence or the intron, under such condition, here the misincorporated amino acid, it successfully recruits during the protein synthesis or during the translation mechanism. So the reason why the specific non-coding sequence or the intron, which is a part of the primary transcript, it has to undergo splicing mechanism so that the specific eukaryotic mRNA, it remains as an mature mRNA or intron-free mRNA. Only mature mRNA or intron-free mRNA, it is capable to export from the nucleus to the cytoplasm in order to participate in the translation mechanism. Is it clear? So here this is regarding the introduction of RNA splicing mechanism, which is most commonly observed in case of eukaryotes. So here I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.